Magis Day to all. I am Ara Alejandra IZT Umlas, and this is the group presentation for essay number 2 of Group 1 in Physics. We will be solving 5 equations that are related to work and energy. Problem number 1. A 12.0 kilogram package in a mail sorting room slides 2.00 meters down a chute that is inclined at 53.0 degrees below the horizontal. The coefficient of kinetic friction between the package and the chute surface is 0.40. What is the net work done on the package? Now, the given properties in this equation are the following. The mass of the package, which is 12.0 kilogram, the x are the total distance traveled by the object, which is 2.00 meters, the inclination of the chute, which is 53.0 degrees, and the coefficient of kinetic friction, which is 0.40. The problem asks us to find the net work done on the package. First, we need to determine what types of work are present in the problem. We are going to draw a free body diagram showing on the illustration. There is a work done by friction and work done by weight. We will first solve for the work done by the kinetic friction. We will have the formula of Wf is equals to mu k times x times mg times cosine theta. Substituting the given properties, so we will have this equation. So why is it 127? We will obtain this number by subtracting 53 degrees, which is the given angle, to 180 degrees, since the chute is at an inclined angle. Multiplying this, we will obtain an answer of negative 56.62 joules. Next is the work done by weight. Using the formula, Wf is equals to mu k times x times mg times cosine theta. So we will substitute the given properties just like we did earlier. However, the angle in our cosine is now 53 degrees. Solving the equation, we will obtain an answer of 187.84 joules. Calculating the total work done, we will only add all the answers that we obtained earlier. So the work done by friction, which is negative 56.62 joules, plus the work done by gravity, which is 187.84 joules, we will have an answer of 131.22 joules.
A 4.80 kilogram watermelon is dropped from rest from the roof of an 18.0 meter tall building and feels no appreciable air resistance. Calculate the work done by gravity on the watermelon during its displacement from the roof to the ground. So we are given with a mass of 4.80 kilogram of watermelon and the height of the building, which is 18.0 meter tall. We are required to find the work done by gravity on the watermelon as it drops from the roof to the ground. Thus, we will use the equation for gravitational potential energy. U-grav is equals to mgh. We will substitute the given to our equation and we will be having 4.80 kilograms times 9.8 meters per second squared times 18.0 meters. Multiplying this, we will have the result of our gravitational potential energy of 846.72 joules.
For number 3, the problem is, a spring of negligible mass has a force constant K equals 800 Newton over meter. How far must the spring be compressed for 1.20 joules of potential energy to be stored in it? The given for this problem are 1.20 joules represent the elastic potential energy, while 800 Newton over meter is the spring force constant. From here, the unknown for this problem is the compressed distance. The formula that we will use in order to find the value of the unknown will be elastic potential energy, which equals to 1/2 times K times x squared. Here is the solution. As per the aforementioned given a while ago, we will just substitute it to the formula. The value of elastic potential energy is 1.20 joules equals to 1/2 times 800 Newton over meter as the value of K. After that, we will just solve 1/2 times 800 Newton over meter, and that will result in 400. We can see that the unit of unknown is the x. Thus, let us divide both sides with 400 Newton over meter for cancellation and for the unit of x is squared to the left. Hence, the result for the 1.20 joules divided by 400 Newton over meter is equal to 0.003. After this, we will apply square root to both sides in order to cancel the square at the x unit. Therefore, expressing the final answer with 4 significant numbers, the distance that the spring must be compressed in order for a 1.20 joules of potential energy to be stored in is 5.477 times 10 raised to the power of negative 2.
Problem 4. A 1.50 kilogram snowball is fired from a cliff 12.5 meters high. The snowball's initial velocity is 14.0 meters per second, directed 41.0 degrees above the horizontal. Using conservation of mechanical energy, calculate the speed of the snowball as it reaches the ground below the cliff. In this problem, we will have to find the final velocity of the snowball as it reaches the ground. These are the given values. M is equal to 1.50 kilograms, The angle is 41.0 degrees. V sub 1 is equal to 14.0 meters per second. V sub 2 is unknown. Y sub 1 is equal to 12.5 meters, and Y sub 2 is equal to 0. As mentioned in the problem, we will use the conservation of mechanical energy formula to get the final velocity. But let's take note that Y sub 2 is equal to 0, which leads us to the formula of 1/2 mv sub 1 squared plus mgy sub 1 is equal to 1/2 mv sub 2 squared. With the formula, next we cancel the common value of m. After doing so, we get 1/2 v sub 1 squared plus gy sub 1 is equal to 1/2 v sub 2 squared. Then, using the distributive property, we multiply the equation by 2, which gets us 2 multiplied by 1/2 v sub 1 squared plus gy sub 1 is equal to 1/2 v sub 2 squared. After multiplying, we have v sub 1 squared plus 2gy sub 1 is equal to v sub 2 squared. Then, we substitute the given values to the equation, and then solve. Then, we get 14 squared plus 2 multiplied by 9.8 and 12.5 equals to v sub 2 squared. After solving, we get 441 equals to v sub 2 squared. Lastly, to complete the solution, we square both sides to remove the square and get the final value of v sub 2. Then, we have 21 is equal to v sub 2. Therefore, the final velocity of the snowball as it reaches the ground is 21 meters per second.
Problem number 5. An 80.0 kilogram skydiver jumps out of a balloon at an altitude of 1,000 meters and opens the parachute at an altitude of 200 meters. A. Assuming the total retarding force on the diver is constant at 50.0 newtons with the parachute closed and constant at 3,600 newtons with the parachute open. Find the skydiver's speed when he lands on the ground. B. Do you think the skydiver will be injured? Explain. C. At what height should the parachute be opened so that the final speed of the skydiver when he hits the ground is 5.00 meters per second? So we are given with the mass of the skydiver, which is 80.0 kilograms, the initial height of 1,000 meters, and the final height of 200 meters. We will first solve for letter A, where we are also given with the retarding forces. We are required to find its final velocity. And we all know that the law of conservation of energy is K sub 1 plus U grav sub 1 plus work done by other forces is equals to K sub 2 plus U grav sub 2. Expanding this, we will have this equation. And with this, we will have to isolate 1/2 mv squared sub 2 since we are aiming to find the final velocity. We will first multiply both sides by 1/2. Then, we will divide both sides by m, and we will cancel out this m here. And we are left with v sub 2 squared. To eliminate the square, we will square root both sides of the equation. And finally, this is the final formula. We will substitute all the given properties here in our formula. With this, we will obtain an answer of 24.49 meters per second. Proceeding to letter B, we will answer the question, do you think the skydiver will be injured? So, what do you guys think? The answer is yes. The skydiver will be injured since the speed of 24.49 meters per second is too fast or strong during landing. For the last part of the equation, letter C, we are now given with a final velocity of 5.00 meters per second, and we are required to find the height or the distance in which the parachute must be opened to have 5.00 meters per second during landing. Using once again the law of conservation of energy, we will solve this problem. Then, we will expand this equation into this one. Then, in analyzing the given problem, we will assume that the initial distance, which is the d sub 1, is equals to 1,000 meters minus d sub 2. We will substitute this to d sub 1, and this will be the outcome. Now, we will distribute w sub 1 to 1,000 meters and d sub 2, so we will have this equation. Then we will factor out d sub 2, then we will isolate the d sub 2, then we will divide both sides by w sub 2 minus w sub 1, and this will be cancelled out. This is our final equation for the final displacement, and we can substitute the properties given earlier. In solving this, we will have an answer of 206.48 meters. Thus, the height the parachute must be opened for the skydiver to have a final velocity of 5.00 meters per second when he hits the ground is 206.48 meters.